people hear me? I wonder. Visualization is very intense. Okay, this is better. Yeah, not really. What's going on there? They're kind of caesarean. Alright, how many people we got right now? 7? Okay. It's precisely less than the amount of people that said they wanted it at 12. So I'm gonna wait a little bit longer for people to show up, I guess. Alright, let's get started. How's everyone doing today? So, for asteroids, we can kind of reuse a lot of our code from the second assignment, but in this case I'm going to kind of rewrite it because I think it's going to be faster to figure out. So we need a spaceship, so let's just start making all the classes that we need. We're going to need a spaceship. We're going to need asteroids. We're going to need an enemy. Let's see. What are they referred to? Just bullets or projectiles? What word are they referred to in the assignment? Let me just open that up again. Yeah, just projectile. Okay. And so you're probably thinking, like, there's a lot of files that we just made. But the thing is, in all of these files, we're not actually going to have that much code in them. Each of them will just kind of have slight differences apart from each other. And I'm going to put all these ones in a new filter. Let's see, our asteroids, we got our enemies, we got our spaceship, we got our projectiles. And so the thing that we got to remember is we created these, and when Visual Studio creates them, if we were to open up the folder that they're in, they get placed in the same location as main. So we actually have to move these to the classes folder here to make sure that it doesn't break. I'm gonna put them in a nested folder as well, but it's up to you. Your include statements will be a little bit different depending on if you put them inside a nested folder or not. And since we moved them, Visual Studio might not even have... Yeah, it's not going to be able to... It's going to kind of lose where these files were to begin with. So what we can say is we can kind of fake delete them and then just move them back in. And so for all of these files, we'll also need a CPP, and so we'll probably have to redo the steps when we make the CPP, but that won't be too bad. And so for our spaceship, we can actually reuse this character class here, and so we're just going to include character.h, although we're going to have to go up, or wait, do we? Or is it going to be fine? Okay, it's fine. Sweet. That's wonderful. So we're going to include character.h. And so our spaceship is going to inherit from that character class, meaning that the spaceship will have all of these components, meaning that we don't have to write all of this again. Which is quite nice. In fact, this is basically going to be what the asteroids look like too. It's going to be what the projectiles look like. It's going to be what the enemy looks like. And so for our spaceship, constructors, going to be, we'll just make it the same. Okay, let me just check one thing. I hope the background noise isn't being picked up, being pretty loud upstairs. No more sleep. No Sleep. Did I mention you should buy Radio Violence made by No Sleep? Okay. Ah, crap. All right. Well, if they continue to be loud, I'll have to go up there and give them a 1-2. So our spaceship is gonna have all the same components as the character class. So it's gonna have a sprite. It's gonna have a velocity and acceleration. We don't actually have a Vec2 for position because the position is gonna be part of the sprite itself. And so for our spaceship, its kind of unique components would be that it's going to have a shield. We can have that just be equal to 4 at the startup. It's going to have a number of lives. Any other things? No, I don't think so. We could specify max speed and max rotation, but I think I'll actually do that in the character class here. So we have this velocity and acceleration. I'm going to add a max velocity and a max acceleration. And both of these I'm just going to set to, I don't know, a generic number. We'll see how that goes in testing later on. And so this this velocity and acceleration is calculated in this update function here. I'm going to also add a add force function similar to the one that we had in SpriteLib. Okay, so is this eventually going to be saved as a YouTube video? It is going to be, because it's being live streamed to YouTube. Therefore, it'll be on YouTube when the live stream is done. It won't be available for, like, I think an hour after it's done streaming, because it has to process it as an entire video, but then eventually it'll, like, just automatically convert itself into a video that you'll all be able to watch at any time frame. But I recommend watching it live, because then you can ask questions. And so this add force is going to take a Vec2 force, and I'm going to create that function. And so if you're wondering what shortcut I just did there, I hit, so let me undo that. And so you see the screen squiggly line under this function. That's because, like, the definition for this function hasn't been made. And so if you hit Alt and then Enter, it kind of brings up this this small menu here. And if you just hit Enter, or just click on the first option, it'll create the definition automatically in the CPP, which is very handy. And so if we were to peek at that definition, our add force function is just going to be the acceleration is going to get added by the force. And so in our update function, we should also set the acceleration to 0 after it's done updating. That way, when a force has been applied, it doesn't keep getting applied for the rest of eternity. I should probably explain what's going on here. So Cocos has its own vector library, but I'm also using my own vector library. And this is an extremely quick and dirty way to kind of convert between these two, because I did not make an equals operator. I highly recommend making an equals operator for your own vector library and matrix math to use for Cocos. That way you don't have to write this gibberish each time you go from one or the other. So the spaceship is going to have shield, lives, we have the character, we have max velocity, max acceleration, that's good. These should perhaps be protected because there's not necessarily variables that you want to edit outside of the class. And so the reason why we have protected instead of private is so that the spaceship can still access the variables. And so we have spaceship inherits from character, and if I remember correctly, you will also want to recreate this constructor here. What is it got against that? Oh yeah, we gotta rename it. So like for when it comes to using the Cocos Vec2 class, like you can use it a bit, but as it says in the assignment, like you are being graded on your own math library, the math and physics. Where is it here? Where was it ready again? Let me just search. Yeah, so like all rotations must be performed with your own vector / matrix math. So if this is just the rotations, that's actually handy. In that case, I could say that you don't actually have to use the Vec2 class, your own vector class, but when it comes to the rotations, you will. And so I'll also be showing a way to perform the rotations. If you have your matrix class ready, you can kind of just pop it in into this one variable, and it just works. It's really nice. I guess the max velocity and acceleration, these can be floats, because I'm not going to have different values for either direction. That doesn't make sense. Okay. What I'm also going to have is a float for theta, similar to Cocos, or I mean not Cocos, SpriteLib. We kept track of the angle for how much the sprite rotates, and so we'll use that to calculate with our matrix math the rotation of the sprite here. And our sprite will be, hold on, so this is my own math library here. I can show you guys the header, I guess. You will not need all these functions, I'll tell you now. The ones that we did earlier in class, where we had we wrote the constructor, and we wrote the multiplication for which one of these? Matrix against a matrix. Actually, yeah, you won't even need to use that one, I think. but you'll need your own rotate function, and that's basically the only one that you'll really need. Okay, so now that I'm not using the Vec2 library, I don't need this jank anymore. Okay. Let's see here. So my own matrix, wait, let's see, question. So in a way we can use both Vec2 from Cocos and our own at the same time? Yeah, and so that's what I had actually going on here. Like I was converting between the two in a very quick and dirty way, and it still works. I actually demonstrated this during the morning tutorial yesterday. In fact, does this run right now? Or did I forget to code something recently? Cool. Ah, yes. Okay. I'll be talking about that soon. Okay. I'll figure that out very soon. So we have our spaceship. We're gonna have to remake the constructor. And so this is our load function essentially. In fact, there might be a faster way to do this. Yes. So for our character class, I'm actually going to make a load function that takes in a vec2 and a string. And so these are going to be the exact same parameters as this constructor above. And so what this constructor is going to do is it's actually just going to call this load function. That way, all of this code will be also like attached to the spaceship as long as we call that function. And we can say, we can give it the position and sprite path. And it worked completely fine. I just want to double check that this opened in the right spot. Oh, I actually created the CPP in the same location as the header, so that's convenient. I was scared that it wasn't. So that is right there. That's wonderful. Alright, so we have the spaceship, and if we go to our gameplay scene here, what we can have is we can then use this spaceship. We gotta, of course, include it. And so I have it inside of the asteroids folder, so I have to specify what folder it's in before I can include it. And so in our initialize function, I think, let's see, init sprites. Yeah, okay. I'm just going to throw this somewhere in the sprite function here. Spaceship is going to be equal to a new spaceship, and its position is going to be, let's put it at 50 and 50. And as for the sprite path, I'm going to give it the exact same one as the birds get, just to kind of speed things up. trying to remember if there's any other additional code that needs to be done to get the birds to display. Ah, yes. In order to get the spaceship to display on the screen, we have to tell the scene to add it as a child. And that's going to specify -100 for the Z offset. Wait, what's wrong with that? What am I missing? Oh, I think it's the sprite itself is what it needs. Yes. Okay, sweet. And I'm hoping that displays with no issues. Sweet, we have our spaceship. Oh, wait, what happened to him? He just kind of fell. Huh. I think I might know why. When the character is created, it also gets a physics body. We don't want to use the physics that Cocos has. So we are going to... What is going on with that auto formatting? What we are going to do is make the physics body disabled. Set dynamic. Get physics body, set dynamic, false. So now every character in the scene should have no collision. Those ones might be manually set to true after the constructor. They might not even inherit from character. I think that's why. I have to check what I'm forgetting here, but that does not seem right. I should have just copy-pasted my code from the tutorial. I'm doing this on my desktop instead of the laptop, which I had all the code already written for. Okay. So for our spaceship, what we can then do is we can start adding in our collision, not our collision, but our movement. And so in our update function, come on, it's right there. We can tell the spaceship to update. And then I believe we have some keyboard functions there in the key down callback here. So what we're gonna do is, if you remember from SpriteLib, we created a struct that contained all of our input. So I'm gonna quickly recreate that. I'm gonna have all these be equal to false to assume that none of the keys are pressed at the very beginning of the game. So we have a space key. Actually, it might be better to have an array of these keys. Let me take another look at the keyboard function. Yeah, actually, I think this will be much better this way. Let me see, how many of these keys are there? 219 minus 50. Okay, so 169, I guess. But actually, so instead of actually having all these keys, I'm actually just going to make an array of booleans. And in the initialize function, I'm going to also make sure that... Oh wait, no, not like that. So we have the mouse here. We'll also have input, input. Where is this mouse struck? Oh, okay. That's similar to what we got here. Nice. I guess input should be renamed to keyboard. But you know what? Input's smaller than keyboard, so I'm going to keep it like that. Pressed. Yes. Okay. Cool. In our key down callback, what I can have is I can tell this input dot pressed at, and then we can actually just throw in the key code here and have that equal to true. It's going to complain about that because it's not a number, it's an enum. But if we just force it to be an integer, we then have an array of every single key in our game, and we can set this to true or false, so that way we don't have to perform all the logic inside of this key down and key up callback, and we can instead also have it work outside of these functions. And it's exactly what I want to do in this update function right here, where before it updates, if input pressed, what was the parameter? Event keyboard key code. If the W key is pressed, add a force. And so we're going to want to add a force upwards. So that would be 0 on the X and let's say 10 on the Y. This does not include our rotation functionality yet. In fact, actually, we could incorporate that right here with matrices even, I think. Yes. So in our spaceship, which inherits from character, what we want to add to our update function is calculate the rotation based on theta. And so the rotation should be equal to, and And so this is my own matrix 4. So you would also need to have your own matrix 4 as well, for the purposes, of computing the rotations. It's going to be equal to an identity mat4 which is rotated by oh shoot. Okay, yeah, no. The rotation will be set to an identity. We'll reset the rotation, and then we can rotate it around the z-axis. And so the z is, if the x is, left and right, and the y is up and down, the z is, I mean, I can't really demonstrate it visually on a 2D screen, but it's like into the screen. So the z position of an object won't really change, but the x and y will, because it's rotating around the z-axis. So the amount it'll rotate around the z-axis will be equal to our theta value. And so, with that theta value, what we could say is, if I have a vec4 for the force, and I rotate that by the spaceship's rotation, and so I will actually need to make the rotation public so I can access it out here. I gotta write it this way, I guess. Yeah, okay. The rotation, or the order that you write your operators is the way that they'll work. So I define an operator for a matrix 4 multiplying against a vec 4, but I haven't done one for a vec 4 multiplied by a matrix 4. So that's why it was giving me an error there. And so with this force, we can then add the force to spaceship. And so if they're holding W, if they're holding S, it should be maybe a negative force. If they are holding A or D, what we can instead do is increase or decrease the theta value. And so theta we should also just throw that in public. We could make setter and getters, but it takes too long sometimes. I'm just trying to keep this brief. Or theta plus equals, and so we could try 10 times delta time. Or I'm going to do 100. And then we do the opposite direction for D. And I'm curious to how this would behave. This will be fun. Okay, it does not appear to be doing anything. add force. Why is it not changing its location? Maybe this callback isn't even working. Well, when in doubt, see out. Let's just ensure that these functions are being called. Perhaps my array of input did not actually work as I intended. Oh, they are indeed being called. All the keys. Okay. Oh! The bird is moving. Just really, really slowly. Because the force I gave it was 1. So let's try increasing that that force. For our spaceship, what I'm gonna add is I'm gonna add a float for speed multiplier, and I'm gonna have this actually determine how fast the ship not rotates, but moves around. That way I only have to change this value to change how fast the ship moves, instead of having to rewrite both of these lines every time I want to fine-tune it. And of course it doesn't actually rotate yet because I haven't added in the actual code that makes the sprite rotate. But we can see that I do have the ability to rotate it. That's nice. Okay, maybe this, where was it? Speed modifier. Oh man, let's just increase that even further. Whoa. Okay, really fast. Right, this is where our max speed can come into play. So for our spaceship, or not, actually this won't be part of the spaceship's function, it's part of the character class. We have a max velocity and max acceleration. So in our update function, what we can actually do is, so I've already written a function for this, but what you can do is just clamp the, wait, is this a Cocos function? Oh yeah, this is not my math library anymore. Whoops. This clamp function can take a min and max. Okay, so this doesn't even have the function that I want. But it's alright, because I can just write it again. So if we want to clamp the accelerations to make sure that it's within the, like, so it's never too big, what we can say is that acceleration is equal to acceleration divided by the acceleration normalized. Do they have a normalized function? They don't have an operator for that? What? Okay, right, this is what we want. If acceleration dot get length is greater than max acceleration, we're going to normalize it and then multiply it by the max acceleration, and so that will effectively clamp it. And so here's also another optimization you can do. Is so the get length function uses square root, and so that's a slow function. So if we get the square of the length, which means that we don't actually have to call that square root function, and get the square of the max acceleration, that'll actually be a lot faster than checking if the length is greater than the max acceleration. And so we have this for acceleration, and we can also do this for velocity. And so it's the exact same code, just changing the variable around so that it's velocity instead. So does max velocity have to be multiplied by delta time, I'm wondering. No, I think it's fine. Yeah, that should be fine. Max velocity might be a little too small, so that, yeah, it doesn't move too fast right now. But we can increase these values. Maybe I should also increase the max acceleration. So that actually looks like it's performing kind of like how I would want it. Maybe the acceleration can be a lot more. And so we'll give that a shot. Yeah, that actually looks like it's pretty nice. For our spaceship, or no, character, I'm going to also add a float for the max rotation speed. So that can be adjusted with a single variable instead of having to rewrite it for both of these lines every time I want to change it. But we of course have to specify that it's part of the spaceship. I'm liking this. Alright. So I'm going to get rid of these C-outs. They're not necessary anymore. I'm also going to comment out the debug draw, just because I've gotten a little tired of that drawing every single time now. So now our spaceship can move around. That's nice. And so you might have noticed that the other bird has been rotating this whole time, and so we can use that code to make the sprite rotate as well. So Cocos actually uses quaternions internally, but it's all right because I found a way that you can throw in a matrix and it'll work fine. Let me just find where I wrote that code. Sweet. And so for our update function here, yes, right. Let me just ensure that this works to begin with. And then we can also fix another problem that is with the spaceship. So now the spaceship actually faces the direction that it's going in. It's pretty nice. Of course, you might be able to notice that if I can get my character to kind of go to a standstill. It's kind of rotating around the bottom left corner of the sprite. And so if you remember from the tutorial, or one of the very early lecture slides when we were talking about rotations and scaling, you have to kind of translate it to the origin point of the object that you want it to rotate around. And so we want it to be fixated on the center of the bird. And so this bit of code right here, I'm actually going to throw that into the update function. So that for every object it'll apply this. So let's see here. I'm gonna write some comments just for fun. So in order to get it to fixate on the center of the object, what we need to do is translate the sprite based on the anchor point of the object. And so we need to translate it by, and so this takes in a vec3. And so in our vec3 there will be the sprites. Trying to remember exactly which one of these functions it was. I believe it was the rect. And so the width multiplied by the anchor point or is it 1 minus the anchor point? The anchor point is 0. Okay, yes, this seems right. And so we need to do that for the x-axis and the y-axis. And so for the y-axis, it's the height and the y-axis of the anchor point. And then I'll just throw in 0 point f floating point 0 for the z, because I'm not going to be translating on the z. It doesn't even matter. But the function that I wrote takes in a vec3, so I have to give it something for that last value. And so we're going to translate it, rotate it, and then we translate it again. We actually translate it the opposite direction. So we actually translate it negative the first time, and then positive the second time. And so this should work. Hey, that's pretty good. I'm going to increase the max velocity. So now we pretty much have something close to we had in SpriteLib. Except it's actually even better, because we can actually now specify a unique anchor point on maybe the spaceship, so that instead of it being completely in the center, maybe your spaceship is like extremely long and you want to rotate around another axis, like closer to like the center of mass. It's completely an option. Woo. And so asteroids, we could do asteroids now, I guess. So for similar to the spaceship, I'm gonna copy the constructors, but we just rename them to asteroid. And the constructor for the asteroid is just going to use the same load function that is part of the character class. And what we can actually have in that constructor too is just like in assignment 2, we had to compute random position for these objects. We can do the same thing. And so let me actually open up I'm just going to copy paste code from another bit of code that I've done. Let me see. Let me just grab it. So it's going to load. It's going to generate a random number. So this is actually going to be the random velocity that we want the spaceship or the asteroids to have. And so for this random velocity, I'm going to say negative 100 to 100. And then we can say for the sprite of the asteroids, set position to be equal to the random velocity using our seed generator. And we're going to have to do this for the X and the Y. And then pow. Oh wait, not set position. What am I thinking? Just the velocity is going to be equal to this. Got ahead of myself there. But I will be actually reusing this code for initializing the asteroids. So for spaceships, we can say is actually okay, for assignment 3, does it still require the asteroids to spawn off screen? Yeah, okay. Well, okay, it's basic asteroids functionality for now, so I'm not going to worry about it too much. You guys will be able to kind of custom tune this to whatever you want. So we have one spaceship, but we're going to have a vector of asteroids. So I'm going to make a function for spawning an asteroid. And so it'll be as simple as taking our asteroids list and pushing back a new asteroid. And so for our parameters, we give it a position, and so our position for our new random asteroid, similar to how we made a random velocity. Where is our asteroid? CPP, yes. We can reuse this bit of code for giving it a random position. And so I'm going to give it a value from, let's say, 100 to 500 on the X, and, or let's make it 700, and then 100 to 500 on the Y. And then the sprite path, let's give our asteroids the pig sprite, I guess. And so pigs are here. So, you know, it probably would have been better to have this code. This constructor is actually a lot better than the constructor that we made for the spaceship and asteroids. But oh well. So in our initialize function, we can call the spawn asteroid function a few times. And we'll want to also, this spawn asteroid function will need to add child, just like the spaceship. And this will work better if we have a temporary variable like this. Then we just can push that back to the list and do that, and that will add the asteroids to the sprites. I'll make the asteroids go a bit above the ship. What did I forget? Oh, my bad. Okay. Whoops. Okay, so the Z order I think is 100 is at the front of the screen. So I think 150 is in front. And I think, yeah, so they were actually just drawing behind the background, and that's why we didn't see them. And then we have some asteroids. We're not actually updating them yet, so in our update function, you know, we update spaceship. We'll also want to loop through our asteroids list and update each one. and boom. That's all really cool. Projectiles would work the same as in the previous assignment. And so for the projectiles, they inherit from character. So they're going to take in a position. And similar to, whoa. I'm going to reuse this bit of code here for the projectiles. Whoa. So what this bit of code here is doing is, so in the constructor of projectile, it can also call like the code that is done in the constructor for character. So that way we don't actually even have to say the load function in here. It does the load function of character. And so then our sprite for the projectiles could be, let's see what images we have even. I don't even know what folder they put these images in. Oh right, UA. Okay, so there we go. Got a sprite for the birds, backgrounds, enemies. Okay, there's not one for general. Okay, Photoshop time. You know what? Good enough. I have to remember where this is being saved. So let's see. Was it? Okay, so that's where I saved it. F drive. Cocos. Cocos project. Yes. Right in here. Okay, sweet. And then, so in Outset Avian's gameplay, you know, we're going to have a similar vector list for our projectiles. We haven't included projectile yet. We can make a function for this too. In the scene, update spaceship, we update the asteroids. We're going to also need to update the projectiles. Right, in our gameplay header, I'm going to close all of these. We're going to want to create our spawn projectile function. And just like the spawn asteroids, it's going to be very similar. In fact, the position is going to be just the position of our sprite of the spaceship. Ooh, actually, I just realized. So we have projectiles, but not all of these projectiles are going to be actually from the spaceship. Because if we look at the assignment guidelines, there's also going to be enemy ships, and some of them will shoot at you with their own projectiles. Okay. Alright. So here's what we can do in that case. So we have a projectile. What we can then do is actually, I'm not going to split this up into separate classes. This is also going to need to be public. We can make an enum for the projectiles so that let's see, enum, yep. This enum can be, it's going to basically define whether it's a friendly or enemy projectile. I'm just trying to figure out a good name for it. But in this enum is going to be a player projectile and enemy alliance. I can maybe come up with a better term than that. You guys too. The worst enum name I've ever come up with. I guess team. And so when projectiles are created, instead of actually a position, what we can actually say is we can give it a sprite. And so this sprite won't actually be friendly and not friendly. Yeah, basically. So the reason why I call it player and enemy is, I don't know, maybe we could have a neutral team that also has their own alliance, or say if we add more players, we could have a player 1, player 2, player 3 kind of deal. I don't know. But also with friendly and not friendly, it's longer the type. I mean, we could make it a boolean for like friendly, and then like either set that to true or false. But I like using enums when I get the chance. It's a bad reason, but so this projectile, we want it to come from an object. What object it comes from, we just give it the index of the sprite that's shooting the projectile. Maybe team could also actually be part of character. Yeah, that's actually what I'm going to do here. So each character is going to have a team, and by default they're going to be on team other. You can actually make this a class enum so that you have to type team first. And is it enum class? Is that what it wants? Yeah, enum class. That's the one. And so when the spaceship is created, its team is going to be set to player. Oh, right, it's a pointer. And the asteroids while the asteroids are not going to shoot bolt projectiles of any kind, I'm going to assign a team to them. And the reason for this is for when we get to the point where you actually have to calculate the collisions themselves. It would be handy to have them assigned to the enemy team. This way, when the projectile is checking against what it's colliding with, it can just check, is that an enemy, and then determine what to do based off of that. And so, is it other player, enemy? Yes. When it comes to projectiles too, for our characters, we have teams. Maybe we can also have a boolean for whether the object can even interact with collisions. Ignore collisions. Or not ignore collisions, but ignore projectiles. Or not, okay, not ignore projectiles, but invincible. In the case of I can't even remember how to spell invincible today. Is it just with, yeah, of course, as soon as I type it into Google, like, I type the correct spelling. There we go. Oh my goodness. That was embarrassing. You can also maybe make a boolean for static position. So, you know, the planets aren't going to move around. So, in the update function, what we could have is we could check if it is a static position or not. If it is not a static position, then calculate the velocity and acceleration. And so, like, this could be a little optimization. So, you know, if something doesn't ever have to move, it won't. Okay, so we are setting teams for the asteroids, and so for projectiles, we haven't gotten to this bit yet. The spawn projectile function will also take in a sprite. And also a speed. Why not? What is it complaining about here? Ah, yes, these don't even match up. Okay. So for our header here, we have a spawn projectile. We need to tell it where it's going to be coming from and what speed that projectile should be when it shoots. Creates a new projectile, adds it to the list of projectiles, adds the projectile to the scene. I'm not going to worry about removing the projectiles. If you're trying to figure that out on your own, it's going to be the exact same way the birds and pigs are removed from the list of objects to be drawn. So, you know, just consult the rest of the code in that case. And so the projectiles are going to draw, I'm going to pick layer 50, so they're going to draw like behind this whatever sprite is going to be kind of shooting it. I'm going to make it even smaller. That way, like, the projectile isn't immediately visible when it gets shot. It instead kind of comes out, it looks like it comes out of the ship, or whatever's shooting it. And so, back to this constructor. The position of the projectile is going to be, and so if we were to look at the code and character here, like this load function, you know, we set anchor points and scales. I noticed that they actually have a manual scaling for everything that you load in will be 1/4 the size. You might want to like add an option for being able to change that. But okay, let's see. Oh yeah, this body code. I'd recommend actually just like kind of removing all of it. Because you should not be using the Cocos physics. I set it to be disabled, so it's basically the same thing, but yeah, make sure you don't accidentally do that. Okay, so when we do all this, the sprite position going to be equal to, if you remember from the character update function, where we did this rotation stuff here. Or not? No, wait, not this bit. I was thinking of the movement code. Yeah, like adding this force. We actually kind of reuse this bit of code, and so the position is going to be equal to the position of the origin, but that's already been taken care of in the character constructor. We just need to make sure that we set the rotation too. So our theta is going to be equal to the theta of the object that we're getting. Okay. You know what? Instead of taking in sprite, we're going to take in character, because there's some components from character that we actually need. So I'm going to rewrite this function a little bit. This of course means that we also need to change how the function works in the header here. So that's going to take in character instead. And so the force that we're going to kind of apply to this projectile, and actually yeah, I guess we could do a force. I don't know, it seems kind of silly. I'm just going to make it a velocity instead. Just plain set the velocity. Velocity is going to be equal to the force times the speed. And theta is going to be equal to the theta of the origin. Force is going to be equal to the rotation of the origin times, oh yeah, actually speed could go here, and we don't even have to do this multiplication here. Wonderful. Nice. Okay. This looks dandy. We can then... Wait, what's wrong with this code? Nothing. It's lying to me. We have this... we already have the code for whether the space key is pressed or not. So in this bit right here, what we can say is... projectiles or spawn projectile, and the code it will take will be the spaceship, and we can try 100, I think, as well. And what we can actually do in our spawn projectile function here is when it creates that projectile, not only, so we shouldn't actually have the velocity just be equal to the direction that the ship is facing, but we should also make it add on the velocity of the ship itself. So if the ship is moving right but facing up, the bullet will kind of move in the same direction, like inherit the velocity of the ship. So that, like, say if you were moving backwards and shoot forward, it would look like the projectile's in the same spot, which is what would happen in that case. And this way, if you're shooting in front of you, but you're moving really fast, the bullets wouldn't actually be like falling behind you if they were moving slow enough. So that would solve that issue. The team of the projectile should also be set to the... Wait, if this inherits from character already has a team. I don't need to redeclare team. Whoops. Team should also be equal to the team of origin, of what this projectile is shooting from. And so, with that, I think that is the code we need to get a projectile to spawn. Let's test it out. I hope I didn't mess up the file path of the image. Okay, there's still almost a bit of an issue of it kind of falling behind the player, but I believe that's because of the acceleration. Like since the bird's accelerating when as it moves forward. If I make it do so at least. But if I'm moving at a constant velocity, they are going to be in front of me. Let's see. Perfect. So these projectiles are going to make them quite a bit faster. Maybe there's also a way I can incorporate acceleration into the projectile speed. But it's good enough as is, I think. Okay. Let's see. Is there any... What do you think I should do? Is there any topics for the assignment that you're kind of unsure about? Like which one, what thing should I cover next? Oh yeah, how to hand it in. Right. Let me see if I even have that file on this computer. Do-do-do. Okay, so to submit, here's what you need to like actually put into the zip file. So what you'll want is a folder that has like the exe and like that, and it runs. You'll also need a PDF that answers everything that assignment 3 says. So the report right here. And your source code. So, important to note, you need to submit all 3. If you do not submit these, you get a 0. If you don't submit these correctly, you have running a chance of getting a 0. Because, like, if I can't get it to run on my computer, you're going to be kind of out of luck. Especially since it's going to be the end of the semester, so like I'm not going to really be at the school after December 5th. Besides proctoring the exam, so be sure this is working. What you should do is like after you've performed all these steps that I'm going to go over, after you've done all of them. And you're just about to submit it online, unzip it to another location on your computer, run the exe, and if it works, that's good. Make sure the PDF is in there, make sure that the source code is in there, and that'll be good. So you'll locate your Cocos 2D folder, locate the build. So you can see this directory right up here. Go into the debug/win32 and see all these DLLs. You're going to need to include those with your submission. So if I were to kind of make a fake submission on my computer, let me do so. So assignment 3, submission example. And so I'm going to go to my documents and then Cocos, and we're going to go to the build, debug, win32. I'm going to sort it by type. I'm going to take all of these DLLs, and before I do that, actually, I'm going to create the exe submit. I'm going to show what a not working one is going to look like. Whoa, that was... So let's start with the exe. So final exe. Here's what a broken one's going to look like. Where is it? So if you just give me the exe, here's what's going to happen. DLL error. So you're going to take libcocos2d.dll, I believe even if I just paste that one in, it's going to give me another DLL error. It's going to give me all these DLLs. So like if you forget some of the DLLs, it's going to give you more errors. So make sure that you have all of these DLLs. The exe is going to run, but it's going to crash. And the reason for this is because it doesn't even have the sprites. So what we can do is take our UA folder here that is next to the exe and paste that in, and then now it is working. Ain't that fine and dandy? So this is what your submission should look like. So the reason why this is called UA is like this is our images folder, if you remember from SpriteLib. It's just called UA because since we were using the Upset Avians starter project, that's just what they put all the assets in, because UA for Upset Avians. So this is your resources folder. Yeah, I can do some camera stuff after I'm talking about this mission. So make sure that you have your images, make sure you have all your DLLs, make sure you have your EXE. Okay. So yeah, this is everything that I just went over here. Or whatever you named it. If it ran perfect, you did not do something wrong. So yeah, you can rename that EXE to final EXE. If you don't know how to rename a folder, I'm sorry. I can't help you, buddy. And so that's a final EXE. That's 1/3 of what I want. Wait, when I run my Cocos project, the text window doesn't show up? So wait, the text window, the console window? Is that what you're referring to, Roderick? Or Roderick? Alright, I'm sorry I butchered that. So wait, the text window. Let me look back at this. Text window. Yes, so the console window, I can go over a reason for that maybe not showing up. Oh, so I actually did not copy over all the files needed. I would recommend, so there's a fonts folder, there's an audio folder. So I'll copy those over too. Might as well copy that over. Okay. So then your PDF. Good. And then source code. So yeah, here are the files you can delete. Here's what I recommend. Don't delete them yet. So we take this whole project, and so here's what I recommend doing. So, okay, you see this .vs folder? Do you see how big it is? Delete that. You won't be able to delete it while Visual Studio is open. But so in the purposes of creating a submission, I recommend copying over everything besides that file. So I'm gonna recreate this folder. And I'm going to put everything in it besides the .vs. So this way it actually copies over pretty fast. If I tried to copy over this .vs folder, like, it takes a while. Didn't take so long in that case, but it has to do with my hard drives. On the laptops, it's going to be much slower. Take these classes and basically all these files, paste those in as well. Because this is our source code here. So if you give me this folder and all I have is like main, and like I try to open this solution and I can't build it, I'm giving you a 0. The other, so if we were to follow this PDF here, the code, the files that we can delete are, so the Cocos project cleaner. What is this file? I mean, that's not right. That's it's actually 3.17, but we can ignore that. Let's see. Debug.32. Yes, we don't actually need this folder anymore in the source code. Or, well, okay. We do need it for it to build correctly because of the assets. So I'd recommend not actually deleting the whole folder, but this debug folder, that can be deleted. This res, it's supposed to hold the game icon. So if you wanted to make your game icon have a different icon, you could keep that. We could go back up. Backup. Is there a backup? I mean, I didn't see a backup in this. Alright, so that stuff can be deleted. These OBJ files, those can also be deleted. And so I'd recommend you could just go by type and then just select all the OBJs, delete those. Actually, let's sort this by size. These PDB files, delete those. So what a PDB file is so when the game compiles, it kind of makes this file that makes it easier for Visual Studio to debug the program if something crashes. Like it can find what function it was at when it crashed. Same with this ILK file, incremental linker. These IDB files won't be needed. And so I can kind of prove this. So if we delete these PDBs, I can delete this ILK. If we go by this type, we can delete all these OBJs. That can probably be deleted. Compiled resource script, I'm going to take a guess that can be deleted as well. These IDBs, those can be deleted. These logs, they could probably also be deleted. I don't know what these PNGs are. Yeah, we won't need those either. This T log, that can be deleted. And so we deleted a whole bunch of stuff. And if we were to compare the size of this, of our like source code folder, 78 megabytes. That's pretty nice and dandy, as compared to before we did this. If we were to look at the size of the whole project, it's currently 2.5 gigabytes. And even if you were to ignore the .vs, which is 2.2, that's 300 megabytes. And so submitting 300 megabytes on Blackboard is pretty big. Generally won't like it too much. If we were to, whoops, go back to the PDF here. Okay, you don't actually have to put the report in a folder. You can just have it'd be next to the source code in file exe. Zip all the 3 of the files. When it comes to names, in this case, I'm going to say you don't have to submit it with like as first name underscore last name student ID, because that ends up actually just making it so much bigger of a file name, and it actually ends up causing a slight issue on my end. And so actually what I should say is, so do name it that, but here's what I don't want. For a submission example, I don't want it to be in a nested folder. So here's an example of what I want versus what I don't want. Oh, is this running? Yeah, it's still running. So I'm going to make two zip files. One of them's going to be what I want, and the other one's going to be not what I want. Oh yeah, I recommend actually deleting the WAV file for the theme song, because that is also probably taking up a big portion of space. Just make sure that, so delete that before you even attempt gathering everything for submission, because it is being used in the code for the main menu. So I'd recommend reorganizing that. And so what I want versus what I don't want. So this zip file, if you were to look at it, as soon as I extract the zip file, it's just a single folder. What I want is when I open up the zip file, I should immediately see the three files. If you have a nested folder, what can potentially happen is it could make the submission so large that or not the file size itself, but the file path can be so large that if I try to open up your or unzip your project, it won't let me do it on my computer, because I have, like, when I do the marking, it kind of auto generates a large file path in front of your submission, and so for some certain students, when I got their submissions, I wasn't able to compile their solution because the file path was too long, and it added more work on my end and kind of frustrated me. In certain cases, Windows sometimes won't even let you extract a folder if the file path is too long. And so, like, for instance, one of the second years, they had submitted 2 parts of an assignment, but their part 2 was inside of had a nested folder within it, and it was so long that everything inside of that folder didn't even copy over. So when I opened up their part 2, there just wasn't anything in it, and I thought they just didn't do part 2. And so I ended up originally giving them a 0 until I realized that they had actually done a part 2. Another thing I can recommend is, if for some reason Blackboard isn't working too well for submissions, and you want to submit a Google Drive link, don't leave it as just a comment. Submit a TXT file, like a zipped TXT file with the Google Drive link inside of it at the very least. That way it's more likely that I'll see it, because that was an issue for the last assignment. Right, so this is zipped and this is zipped. And so we can see an example. If I were to put these next to each other, I'll just slightly edit the file name of one of them. 1, 2, 3, 4, 5, 6. I'll move this to here. And here we can see, like, if you have a folder within, the file path is just longer and it's unnecessary. Like, I don't need it. It's going to complicate things on my end if you have way too long of a file name. Okay, yeah, so that covers submissions. Okay. What was it? You asked about the text window not being able to show up. And so I can think of an example why that might be. The first thing I'm going to try is I want to open up this solution just to ensure that my submission example still works. I want to make sure that I didn't delete any unnecessary files because I kind of just guessed a whole bunch of them. So we'll see how that goes. Whoa. That doesn't look good. Appears to be having trouble finding some of the files. So I might have deleted a folder that or a file that I was not supposed to delete. So kind of double check. Maybe I'll try adding some of these files back in, see if it will still work. No. Okay, I was definitely way too quick on the gun for deleting random files. So what I'm going to do is copy over all of these again and try again, essentially. No. Huh? Wait a second. Let me try adding these again. Same with my math library, I guess. Strange. Alright. I'll have to figure out why that is. So if I were to take a guess, what? Oh, yeah. No. Probably one of these two files here. Like, that's what it should be. I'm wondering if these didn't correctly get created the first time. So if this is our original upset avians, if I open this up, okay, this is what happened wrong here. So if you don't know already, this this // here, what this represents is it going up one folder, essentially in the file explorer. So if I was in the directory of debugs.win32, if I were to go up one folder, I would end up at this, and then I would end up here. And so what's happening here is it's going up 2 folders, and the original name of the project, essentially, if we're starting here, we go up 1 folder, and it goes up another folder, and then it goes into the main folder, then it goes into classes. And so because I renamed the folder that my submission was inside, it ended up breaking this. So what we can do to fix that is we can remove one of the times that it goes up a folder along with that reference. And so this is definitely something that you should check in your own code to make sure that you're doing that correctly. And that will get that to work. And so if I were to go to my example submission and try that again, let's try deleting all the unnecessary files again. Yeah, don't need those. Don't think I need those. Won't need these. Don't need this folder. That's looking good. Now I should be able to, okay, I can delete the .vs again. Should be able to open this, and it should be able to compile. Haha. And it does. Wonderful. Yeah, so that's kind of an example of what I would want for a submission. When it comes to zipping it up, you have 2 choices. You could either submit it as a zip or a 7-zip. Just keep in mind, if you submit it as a zip, definitely take a look at the file size, and if it's like more than, I would say, if it's like greater than 100 megabytes, try again as zipping it up as a 7-zip, because it'll probably end up being a lot smaller, and that'll submit to Blackboard a lot faster, which could give you a little bit more time in the end, if needed, for those last like few minutes of panicking for the deadline. Alright, so we got our queue of questions. So running the Cocos project and the text window doesn't show up. So one reason I could think of that it's not showing up is, so let me just close some of these. Close current tab. Okay, cool. We're going to go back here and open up the solution. Oh, that's strange. Oh, 'cause, the filters, I didn't adjust the filters too. So that's probably what happened here. All these files in my, got all messed up. But I can just drag them back to their original positions. Okay, cool. Okay. So one reason I think that this console window isn't showing up is if you go to the project settings, or the properties, and go to, well man, I have to remember which one of these it is. Let me consult one of my projects that I did this in, because I did it once and I can't remember what I did for the life of me to do that. So this will only take a couple seconds. Just gotta open it up. Aha, okay. So if you go to your linker settings, there's system, and so you'll see this subsystem option here, and so this basically specifies how it kind of opens. And so since it's set to Windows, what the heck? Well, why did it open up there? It might not actually open up with a console window. So if you want to ensure that that console window is opened, you can just set this option right here. I'm actually kind of confused at how it was able to, why it was still opening up the console window. Maybe Cocos overrides it if you have a print statement of some kind. Okay, so that does not work. Native does not work. Okay. But you can try, so you can set it to console, and oh, that also causes an error. Huh. Crap. Okay, well, I don't have time to figure that out right now. But when it comes to the console window, it's not necessary. I don't need it. I'm not going to be looking at it ever, unless like I get an obscure error in one project, and if it can help me in any way. But I'm not going to be spending too much time ever trying to figure out how to get any of these projects to work. I expect them to work out of the box. As for camera control, so I remember seeing, where was it? Something about a camera here, camera target. never saw it being used.
Okay. So if you ever want things to follow the camera, here's what I recommend doing. So if you want it to always follow the spaceship, for everything that you're adding as a child, so the projectiles and the projectiles, the enemies, we're going to want another sprite that is our that is the one that we have, like this camera target right here, and so this camera target, we can set its position to be equal to the spaceship's position. In fact, we would want that to be called every update. And so we get the position of the object, and so for every other object here, so for spawning asteroids, we want to actually add them as a child to this camera target. Or wait, hold on. Yes, I believe so. I believe this will work. Actually, it's going to be hard to test this because oh boy. I should add this to the background as well. To test this out. I should have added to everything. Right. Okay. When the game's getting initialized, spaceship will be the first thing, followed by the camera target. And so actually, the position of camera target is going to be the opposite of the spaceship's position. And so camera target set position is also going to be the negative of the spaceship's position. So this will allow it to move around the screen. There's still a little bit of configuring it needs. Trying to think of why that would be. There might actually be a faster way that I'm not thinking of for some reason. Let me set all this back again. Cocos might have this already built in. Okay. I got an idea. This is pretty dirty, but it might be able to work. Okay. Yes. Okay. So for the character update function, I'm also going to add I'm going to add another version that also takes in a mat4, or no, another sprite. And so this update function is going to actually be the exact same as this one, just that this other update function will instead call the other one with still with delta time, but an identity matrix. All right. Yeah, I specified that to take in the sprite. Okay, I'm going to have it taken to mat4 instead. And so our rotation is going to end up getting rotated by the inverse of the camera. You can make this a const. All right. And then for these update functions that we have here, I'm gonna using my matrix for. Oh, so when you say the opposite of the spaceship's position, do you mean going from XY to negative X, X negative Y? Yes, essentially. And so this is actually kind of a topic that's done in second year for computer graphics. But in order to have a camera in a scene, and you want the camera to move around, so when you move the camera to the right, essentially everything in the scene moves to appears to move to the left. And so it's simple for positions, but when you take into account also rotations, you need to get like the opposite rotation, and so that's where our matrix inverse comes into play. And so we have our mat4 is going to be equal to let's see, camera view is going to be equal to
going to be offset by, what did we call that again? The camera target. Okay. Target, get position Y and 0. And so I'm just going to kind of throw that in as a extra parameter for these update functions. Crap, the background is just a sprite. Shoot. This is assuming that they're a character. Crap. We'll be able to see if this works in some sense. Okay, that does not. Okay, let's ignore that bit of code then. Pretend that part never existed. You know, I completely forgot about the camera stuff. But essentially, if you want the spaceship to always be in the center, you do need to offset everything by the spaceship's position. In order to get it into the spaceship's movement space, or like the position space of the spaceship. Oh my goodness, that really couldn't be worded any worse. Can't really be done any better with the naming of everything in this project. All right. So I'm going to pretend that function never existed. Okay. Whew. We have the backgrounds, and we need them to move around. Why have I not consulted the good old PDF yet? It's probably got something in there. Nope. Okay. One of the potential solutions, though, you could come across for this is, so instead of having the the spaceship move, you could actually have it fixated at the center of the screen and move every other object based on the spaceship's input. I wouldn't recommend that, though, although I do believe the camera target is definitely the way to go for this. I just gotta remember how this code would actually be done. yeah, if we were to take all these add childs and add the camera target, so I'm not going to worry about the things that have nothing to do with our game, like the pigs, and but right, okay, yeah, that's one thing we can do, is actually make this camera target we could make this, instead of a sprite, a character. New character. Inaccessible. Right. Is that const or must be modifiable? Oh crap. Wait a second. Right. We give this the origin position. There we go. Sprite, set position. We don't actually have to set the position. I'm gonna just quickly rewrite the code that I've done. Alright. Remove some of this code. Sprite. So what I'm doing here is I'm actually parenting all of the objects in the scene to the camera. So when the camera moves, it'll move them. Maybe I don't even need to give this. Maybe I can just say, oh wait. Character marches to... So camera sprite doesn't actually have a
right. Oh wait, no, this takes in a file path. Right. Oh my goodness. I've been dumb this whole time. I don't know what I've been doing. I'm just going to leave that an empty file path. And then it should draw just nothing. Okay, wait. What? Ah, okay, I was not able to create the sprite because this path doesn't exist, of course. Okay. Workarounds will have to be found, of course, but this one will do for now. Crap. No, this won't work without me having to completely rearrange a lot of code. So I'm gonna try to figure out the easiest way to do this would be let's revert the code a bit. I'm thinking way too hard about how I would do this as an advanced user. Cocos, like, has got to have a simple way of doing this. So if we look at our scene, let's see what we can do in our scene. Yeah, okay, here we go. Oh my goodness. There's just a Cocos has a camera. What have I been doing this whole time? Okay. Does this return a pointer? Yeah, it does. Okay. So can I set the disposition of the camera to be the position of the spaceship? Is that easy? Is it just one line of code? It's doing something. Okay, that's strange. But another thing that we can do is we can go over and wait. There might be another thing that I'm looking at. If we were to print out the amount of cameras, what do we get? If we get cameras that size, what do we end up with? I should probably put that on a new line, but oh well. 0. Okay, so there wasn't even a camera to begin with. Interesting. Well, the way we can work around when it moves. Oh yeah, I commented it out. The way we can get around it moving is if we just set the background image to move with the ship as well, should be fine. So actually, let's get an actual background image. And so, I don't know, I'm gonna do a really weird way of adding adding stars. We'll see how this goes. If I do this. Still a lot more than I expected. Well, okay, I can think of a way around it. There's some stars. So we might need this code here. We might not. Well, we'll see very soon. So we're setting the position of the camera, and then we're going to set the position of the background to be the position of the camera. That might go well. So let's see. I might need to offset this again, but we'll see. Sweet. Oh right, there's still the second background image. But if we set that one to draw behind the other background image,
So can we use the camera class that Cocos provides? So I'm gonna have to actually say ask Hogue on that one. I'm gonna send him an email after this, but there's still a bit of time, fair bit of time before the due date of the assignment, and so the camera isn't too difficult to do if you have your own matrix library kind of set up. And so I assume it's not necessary because, as it said in the assignment guidelines, rotations have to be performed with your own math, and we're not using the camera to rotate the scene, we're merely using it to position the screen. But okay, let's see here. So we have spaceships, and they do stuff. It's weird how it takes a while before it actually sets the camera position. Oh well. This is actually pretty cool though. Huh. All right. Yeah. Were there any other questions on Q? See, the camera works, the console window. More camera questions. Let me check the... Okay, that's cool. Sweet. As it comes to, was it doing the enemies and the planets? So the enemies, all that would really need to be done is so you just check. You would actually really have two collision checks for them. A collision check for whether you're actually colliding with them, and maybe not. Okay, not a collision check, but so you need to check if the enemy ship can see you. And so to see you, that means that they have a cone of vision, and so if you remember from one of the earlier lectures, dot product will come into play for calculating that. Along with, you'd also want to check whether you're within a certain amount of distance, so that their vision eventually peters off, so that they can't see forever in one direction. And then if you have some kind of enum for your enemies, so that you specify whether they're kamikaze or shooting, you could have their update function behave a little bit more differently. So like if it's a kamikaze, then it starts moving, adding a force in the direction of the player. If it's a shooting one, it rotates and spawns projectiles itself. And so, yeah. The grappling hook, that might be one of the most difficult parts of this assignment. That one you would have to write some unique logic for when you press the space bar. Instead of shooting a projectile, it shoots another object that once it connects with an object in range maybe, then it clamps the distance between the player and that object temporarily. And so I think that could work easily with that definition I just gave. energy cubes would just be another object that you collide with and don't die. So for the boss, we're good to give it a shield that needs to be taken down first, right? And so yeah, you have to destroy it 3 times. And so yeah, shooting it once is not what I would say destroying it. Like the enemy ships would be the ones that, like, you know, get destroyed in 1 hit, but the boss fight would have different, like yeah, it would have its own health bar like the ship, and you could give it 3 lives, just like the regular spaceship. In fact, an interesting thing that you could do is you could almost maybe base off the player spaceship and the boss spaceship with the same class. I wonder. Could potentially, you have a spaceship, and where is that spaceship? And a boss. And you load in the spaceship. You could also load in the boss. And oh yeah, for the projectiles, let's go over a simple collision with the asteroids and enemies essentially. So we have our update loop here. We update the projectiles. We update the asteroids. So when we update the projectiles, we could also loop through all of the asteroids, and then you know, check their distance. If projectile hits sprite, did we have a get position function for these? Just oh, we do. Okay, so we don't even have to get sprite. That saves us a little bit of typing. That position minus the position of the asteroid. Is smaller than the radius of both. So I'm just gonna say the size is it to get wrecked. What was it in character.cpp? Get sprite frame. Get wrecked in pixels. Oh my goodness. Yeah, I guess we could... Actually, in character.cpp, we could just have a float for radius, so that we don't have to type that every single damn time. And then in this load function, radius is equal to all this junk.
Okay. So we have the radius. Then we just say radius plus asteroid radius. And so if they're colliding, you'd actually want another if check. Because before you even care about calculating whether it should collide, you'd want to know whether the projectile's team is not the same as the same team as the asteroid. We also need to actually get the length here. Okay. So if they're not in the same team, check at their collision. If they do collide, for our asteroids, we do have a Boolean for alive. We could set that to false. And so then after it's done going through all the projectiles, what we could then do is loop through all of the asteroids and remove all the ones that we don't need anymore. And so asteroids at I. Minus. Right, it was dot erase. It was erase at I. Or begin plus I. That's, yeah. Oh my goodness. There we go. Perhaps it's better to loop through this the other way around. I think that's legal. And so if the asteroid at I is not alive, delete it. For the enemy spaceship, I'm also going to add a function here. So spawn projectile from the boss, and these projectiles are going to go in that direction. And I'm just gonna have the boss spinning right now. I'm just trying to make a proof of
concept at this current point in time. And then for our asteroids, I'm going to make a whole bunch of them. Where's our spawn asteroids used? So I'm going to have it start off with 100 of these being generated. Oh, what did I forget? Oh, yeah. Right. Huh. Here's what I get for just speeding through this remove process. In fact, since I sped through this, I realized that I also forgot an important bit of code for erasing the asteroids, and that's that, oops, similar to if we were to look at how these pigs are removed, we have a should die function here. It calls this kill function. And this kill function essentially tells it that it needs to actually remove it from the Cocos engine itself. So I'm going to say asteroids that I kill. And so here we can see that the projectiles of the boss aren't actually killing the asteroids because they're on the same team, but if I were to try to shoot the asteroids, they get wrecked. Wait, why did those... Oh no, those weren't asteroids, those were just the pigs from the original scene. And this game's getting really stuttery because these projectiles that the boss is shooting, they aren't getting deleted. So there's just a whole bunch of them. So wait, the boss is supposed to be rotating, but he's not. And I realize the reason for that is that we're not actually updating the boss either. So we update spaceship, we want to update the boss. And so we could actually make a timer for the boss so that it's not shooting every frame. So, this is static float, timer, I'll just equal to 1, timer minus equals delta time. If timer is less or equal to 0, timer is equal to 1, and I don't know why I put this in brackets. And spawn a projectile. Now this boss is shooting. Oh, it's fun. And so you can use like simple like sine and cos math to have the boss, if you want it to always face the player, Another thing you could do is like not even care about the rotation of the boss itself, and just have its projectiles, the force be in the direction of the player, so that like the boss doesn't have to rotate to fire at the player. It's another option. But yeah. So I think that's it for today. Hope you guys had a lot of fun and realize that the assignment isn't actually too difficult. Like all of the hard parts are already done. Just like organizing the data, all that's left is the actual math. And the math is it's just the same as you did in assignment 2. You're just doing the collisions. Just some basic scripting, and so yeah, I hope this helps you guys get some really awesome assignment 3s. I'm looking forward to them. Until next time, take care.